Okay, so we're looking at the sum of a geometric progression. Just like we had the sum of an arithmetic progression, we can do a sum of a geometric. So if we're going to do it laboriously, we just have the first term, plus the second term plus the third term plus up to the last term. Okay, but there's a formula. Okay, so let's have a look at how the formula is derived. Okay, so we start off with just the sum. Okay, so the sum of n terms is a plus ar squared. Now, just to show you how the formula comes about, I'm going to write the second last term, okay, the second last term, and the last term. Now, you don't have to worry about where the formula comes from, but I just need to show you where it comes from. Okay, so the trick in the formula is we multiply this sum, we multiply it by r. So what happens is the first term moves across 1, a times r is ar. The second term moves across by 1, etc., etc. So at the end, the second last term moves across and matches up with the last term, and the last term, when you multiply it by r, you end up with arn. Okay, so the trick now is we subtract, and we're subtracting uphill, so we subtract the second line minus the first line, and what happens is all these terms in the middle, they just disappear, and all you're left with is this term at the end, arn, minus the first term, because we're subtracting uphill. Okay? Now, have you look, we've got Sn as common, so we factorise Sn. So we have Sn bracket r minus 1, and on this side we've got a common, so I take out a, and I get left with rn minus 1. And then just divide by r minus 1, so that goes to the bottom, and we have what's going to be a really neat formula. Now, if we had subtracted the other way, we would get this formula. And both formulas are okay to use, but you only have to use one of them. Traditionally, this one was used when r was greater than 1, and this one was used when r was less than 1. But you don't have to, you can just use the one formula. You don't have to know where the formula comes from, you just have to know the formulas. So let's look at some examples. Okay, so we've got to find sum of 8 terms for 1 plus 3 plus 9. And again, I'd like you to get into the habit of just writing a little legend on the side. So a is 1, the common ratio is 3, and we've got 8 terms. So again, Sn equals a rn minus 1 over r minus 1. So we've got a rn minus 1 over r minus 1. That equals 2, and then just chuck it on the calculator, and you get 3,260. Okay, copy and come across when you're ready. In example 2, how many terms do we need in the same pattern, but this time we're given the sum? So in the legend, we've got a, we've got r, we don't know what n is, but I know what the sum of the terms is or are. Okay? So we put the 1,093 out the front where the Sn equals. Again, Sn equals a rn minus 1 over r minus 1. So put the sum out the front. A is 1, r, we don't know what n is, so we just have to leave it, and r minus 1, which is 2. So the first thing I do is I cross multiply the 2 off the bottom to get rid of the fraction, and the next step is add 1 to both sides. Now here, because you're told that there is a sum, you could just do guess and check with powers of 3, but we can go straight to logs. So what I'm saying is, because you're told it is a sum, this number here will be 3 to some power. It ends up being 3 to the power of 7, but otherwise, let's just use log. So we take log of the answer divided by log of the base, and you get n equals 7. So that means we need 7 terms to get a sum of 1,093. Copy and come across when you're ready. Okay, last example. How many terms are needed in the series 7 plus 14 plus 28 plus ... to get a sum that exceeds 1,000? So in the legend, we've got a is 7, r is 2. We don't know what n, but rather than the sum being a number, it's greater than a number. So I'm just going to set up a little bit differently rather than... jumped it. So rather than having the sum out the front, I'm going to put the sum out the back, and we have to have it greater than 1,000. So 2 minus 1 is 1, so that means that that number just disappears. And then to get rid of the 7 here, you can't multiply through, and we just divide. So just divide by 7 both sides, and you get this silly number 142.9, and then add 1 to both sides, you get 143.9, and then just take log of the answer divided by log of the base. And it jumps up again too quickly, and you end up with 7.16. Now, because n is greater than 7.16, that means we need to go up to the next number, so we need 8 terms. Okay, so copy and come across. So now we're looking at exercise 5F from electronic textbook, and that's all you have to worry about. Thanks, bye.